Answer the following questions. Why does a paramagnetic sample display greater magnetization for the same magnetizing field when cooled? Right. So answer for this question is owing to random thermal motion of molecules, the alignments of dipoles get disrupted, right, at high temperature. Because see, alignments of dipoles get disrupted. See, uh, dipoles are earlier, these are dipoles randomly situated because of high temperatures, right? If during the magnetic field, if they are aligned, but because of high temperature again they disrupted, so on cooling the disruption is reduced, hence paramagnetic sample displays greater magnetism when cooled. Second question, that is, why is diamagnetism in contrast almost independent of temperature? So the induced dipole moment in a diamagnetic substance is always opposite to the magnetizing field, right? If dipole moment is in this direction, so it is always opposite to the magnetizing field. Hence, internal motion of the atoms does not affect the diamagnetism of material because of opposite direction of both the diamagnetism of material is not affected. Then third one, if toroid uses bismuth for its core, will the field in the core be greater or less than when the core is empty? So here bismuth is a diamagnetic substance, hence toroid with a bismuth core has a magnetic field slightly greater than the toroid whose core is empty. Then next, is a permeability of ferromagnetic material independent of magnetic field? If not, is it more for lower or higher fields? So here the permeability of ferromagnetic material is not independent of the applied magnetic field. It is greater for lower field and vice versa. Then next, magnetic field lines are always nearly normal to the surface of ferromagnet at every point. This fact analogous to the static electric field lines being normal to the surface of a conductor at every point. Why? So answer for that, here the permeability of ferromagnetic material is not less than 1. It is always greater than 1. Hence, magnetic field lines are always nearly normal to the surface of such materials at every point. And the last one, would the maximum possible magnetization of a paramagnetic sample be of the same order of magnitude as the magnetization of a ferromagnet? So here answer is the maximum possible magnetization of a paramagnetic sample can be of the same order of magnitude as the magnetization of a ferromagnet. This requires high magnetizing field for saturation.